Okay. Good afternoon, everyone. Do you feel recharged? After having a lot of insight from the previous session, now we are going to listen to another session.
Okay, without further ado, let's move on to the next session. The topic is AI and IoT in smart agriculture, how young innovators can shape the future farming, by Mr. Andri Prima Nugroho, Ph.D. from Universitas Gadjah Mada, Indonesia. And this session will be led by our moderator, a lecturer from Faculty of Agricultural Technology, Dr. Priska Rinda Lestari. As we begin, let's take a moment to introduce the moderator and her background in the field. Dr. Priskarinda Lestari is an environmental engineering researcher with expertise in plastic pollution, water quality, and agricultural waste management. She completed both her master's and doctoral studies at 10 November Institute of Technology under the Indonesian Ministry of Education Fast Track PMDSU Scholarship. Her doctoral work focused on plastic waste distribution and degradation in river ecosystem. Over the years, she has contributed to research on sustainable materials and microplastic impacts and has been involved in collaborative program with institutions across Southeast Asia, Japan, and Europe. Without further ado, please welcome our moderator in this session, Dr. Priskarinda Lestari. The time is yours.
Okay, good afternoon, everyone. How are you feeling today? I think some noise are still missing. How are you today? How many countries? The participants here? I think 9 countries. 9 countries. From Indonesia, wave your hand. Okay, most of majority is Indonesia. Another is Malaysia. Okay. Um, and then I see some from Philippines. Okay, mabuhay. And from Vietnam. Okay. And another country is from, I think, where is that, those? 9 countries? Ah, yeah, Turkmenistan. Okay. Ah, nice to meet you. And others countries? Oh, okay. Yeah, I believe a lot of countries. So it's such a great honor for me to meet all of you here in our next session in the second day of summer course. I believe all of you have a very interesting and also eager to learn in this time. And fortunately, we have our expert, which is Andri Prima Nugroho PhD, or I can say Dr. Andri, which is also my sensei in our laboratory. And right now, in this activity, I think he will deliver the materials about AI and IoT in smart agriculture, how young innovators can shape the future of farming. However, before we continue to the materials, I would like to present the curriculum vitae of the presenter. Okay. So, yeah, right. Let's just. Okay, so our honorable speakers in this afternoon is Insinyur Andri Prima Nugroho, STP, MSc, PhD, IPU, ASEAN Eng, and I believe it is APEC Eng, soon to be. He is a lecturer, actually associate professor from Department of Agriculture and Biosystems Engineering, Universitas Gadjah Mada, Indonesia. He completed the educations at bachelor degree at Faculty of Agriculture Technology, Universitas Gadjah Mada, and pursue master's and doctor's degree in Kyushu University. And also he has a focus on research cluster in Smart Agriculture Research Center, information technology in bioproductions engineering, precision agriculture, and also agricultural information system cluster, International Commission of Agriculture Engineering, and a lot of publications. However, without further ado, please welcome our speaker, Dr. Andri Prima Nugroho.
Okay, thank you very much, Dr. Priska, for your kind introduction, and good afternoon, everyone. Are you full now? I mean, you can enjoy the food, Yogyakarta food. I'm not asking for Indonesian people. Maybe they already enjoy. How about from Vietnam? You can enjoy the Yogyakarta food. To how to say, not so spicy, I think, right? Yeah, yeah. For Vietnam's like spicy food, I think. My friend from Vietnam, they like spicy food. How about you? Exception is exception. Okay. How about the other country? For Malaysia, are you enjoying the Yogyakarta food? Nasi lemak? No. How about from Philippines? How about Yogyakarta food? Okay. Okay. Yeah. From which country? Mr. Abdullah? Yeah, from Yemen. How about the Indonesian food? Really? How about the portion? Too small? Yeah. Yeah. Usually big size for brother from yeah. Okay, I would like to share my screen first. Okay, I also want to make a greeting to the audience in the online. Also, hope you can see my slide in your screen. And thank you very much for the opportunity for me. I would like to share our research and the committee asking about I hope to deliver a title like this one, the AI and IoT in smart agriculture, how young innovators can shape the future farming. And yeah, hopefully you can answer this question, not only me, because the committee asked me to ask you. So then I also, okay, I introduce myself first before I'm asking. Maybe Dr. Priska already mentioned my CV, and hopefully we can know each other. And if you have any research interest in the field of precision agriculture or smart agriculture technology, maybe we can work together for research, maybe for collaboration. And yeah, currently we have a smart agriculture research center. If you see in the corner, we have launched our new logo. The previous logo is like this one. Maybe some of you already follow. If not follow, so please follow our Instagram. Yeah, and this is the old brand logo, but the new logo is that one. The how to say, the leaf with the various color. So this is called the Smart Agriculture Research Center UGM. If you have any interest, please kindly check in the Instagram. Currently, our team is make an expo in Agritex. This is a big forum for, expo in CI Expo Jakarta. Maybe you can check after this class. And after the introduction, I will like to ask you about this kind of question. How young innovator can shape the future? Kindly scan this barcode and please answer the question. Any words you come up in your opinion, please write it. Young innovator, and how about to solve the problem in agriculture in the future? Yes, Menti. I use Mentimeter. Then I will show you the result after that. Yeah, while waiting, because I give you an assignment to this one, because we are dealing with the technology. So I don't want to make a tutorial step by step how to do this one. I believe that you already know how to do this. All technologies. Still one, okay, two to answer already come up. Okay, I will share. Okay, this is some words that come up in your mind if I'm asking about how young innovators can shape the future farming. AI implementation, collaboration, smart, technology. Okay, we are waiting for your answer. IoT. Anyone familiar?
Thanks. I think the answer is very various.
Yes, we need the various answer because we come from the various background. Yeah, hopefully after this class, you will have a point of view regarding the what is smart technology and how can it answer the problem in agriculture based on your background. Brave, clear, to learn a lot of trends. Okay. Research. The interesting thing is providing affordable technology, the keywords. Providing affordable technology. It means the technology can be used for everyone. Not expensive technology, not, let's say, sophisticated technology.
Yeah.
This is one of the keywords of my lecture. Balance traditional, this one is also. Smart farming, yes. There are no such a word that is major. Almost collaboration and technology is the biggest. Brave. Yeah, okay, I think it's enough. I think enough. Everyone that not submit yet? Difficulties for submitting? Okay, okay, okay. There is no tutorial for that one. And yeah, from this kind of pretest, we can see that many idea come from the different background that will deliver and bring what kind of technology is suitable for that problem. Okay, some of the words is relate to our core course in today's session. Okay, I will stop and continue. Yeah, anyway, thank you for the giving such kind of words and also response. This is one of the parameter that you listening the lecture. Because the challenge in the afternoon session, only two. The first is the full stomach, and the second one is sleepy. If it's to come to you, then my task is filled. Okay, regarding the precision agriculture and smart farming, let me share you some idea. This is the picture that I saw at a time when I first come to our university in Japan. My professor asked me, like, Andri-san, what kind of thing that you want to study in my lab? And I show this picture to my professor, and he said, "Oh, you have good, you have good taste for research." They said, "Good taste for research mean that this is very expensive technology." What mean expensive? Because, for example, in our country, in Indonesia, in Malaysia, in Philippines, we can grow plants naturally outside. And why we need to build such kind of technology? We call the plant factory. And I said at that time, Sensei, I want to study this plant factory here. And my sensei said, really? Really, you want to develop this kind of technology in Indonesia? It's not possible because this is sophisticated, expensive, and high price. How about this one? Is it also expensive? Do you think it can be used in Indonesian agriculture? Or Vietnam, maybe, do you think? Yeah, maybe 50 years later, maybe. Maybe if the people need the precise application, maybe arm robot is one of the option. Or in industrial, agro-industrial sector need this one. But for the practical implementation, need high cost. And the other one is, how about this one? What kind of things if you see this picture? Is it farmer or owner of the plant factory? Owner of the plant factory, yeah. He is a manager of plant factory. But he can manage the plant factory, the big area of plant factory, maybe only he and the 3 staff. This is in Osaka, in Japan. Yeah, only 3 staff they can manage the plant factory, the whole plant factory. Yeah, after this session, we will go to our plant factory, mini plant factory in our basement, and we can see the small scale of the plant factory after this one. And maybe someone asked me, how many people manage the plant factory? Currently, we only one people manage, 1 hour, 1 student manage the plant factory. Maybe next time I have to make a photo session for him like this in order to grab maybe investor, they will come and make a big one for Indonesian. But I think, yeah, maybe this is one of the good maybe motivation for young farmer that they don't have to be a farmer, but they have to be a manager for farming business. Do you know the difference between farmer and manager of farming business? Do you know what is the difference? Farmer and manager of agribusiness. Who is the on big money? The manager, yeah. Everyone should be considered about to be a manager, not as a farmer. Farmer maybe in the connotation maybe it's like a buruh tani in Indonesia, like labor. In Indonesia, maybe if I say farmer, maybe the mind about the words is belong to labor. They work from morning to afternoon, really hard under the sunshine. Maybe they don't need sunblock. No sunblock. Yeah, it's really hard. How about the manager? The manager, they manage the production process from the start to the end, and they manage the flow of uh, the money they have. So maybe everyone want to be like this, I think. If they say that, what is your goal after finish your study? I want to be a manager of the agribusiness. I think the shoot is like this. Yeah. I hope everyone agree. And After I realized I finished my study in Japan and I come back to Indonesia, come up this question: how about the tropical agriculture production in Indonesia? And I found this one. What do you think? Can you find this kind of activity in the field? Yeah, at least they know the technology because they use a laptop in the field. Maybe we are positive thinking. They are checking the weather condition in the field and also manage the cash flow for selling the vegetables. And maybe they are discussing about the strategic for exporting vegetable to Vietnam, to Philippines, but not to Thailand. Thailand is better for the vegetable. Maybe we are positive thinking about this one. But I think the technology is now is nearby. If we are thinking about, oh, IoT, AI is far, but no, now is very close. Now everyone, I think, familiar with ChatGPT. ChatGPT, which assistant do you use usually now? ChatGPT? How about the other one? DeepSeek? And then the other? Gemini. The other one? AI Studio? And then? Purple? Yeah, it's my first time. Oh, another one? Grok? Yes, Grok by X, yeah. Meta? Yeah, already familiar now. Before, maybe 5 years or 10 years ago, if we are talking about AI, it's a little bit far. AI, what is AI? How to use it? How can we use to help us for daily use? It's very difficult. But now, I think easier. IoT now is easier. That's why now, if people know the technology, I think they can adopt the technology. Do not look at the outfit, but look at the gadget. The gadget. The gadget is maybe you use laptop, so it means the laptop is higher than the smartphone for the complexity. Yeah, this is the good idea, good start. And if we start from the problem, what is the problem of Indonesian agriculture? We have 5 points here. The climate change, pandemics, we realize that the pandemic is destroy everything, not only about the culture, but also the education. If I remember, the student who are studying in university during pandemics, they miss maybe 2 or 3 years. They miss their friends, they cannot make a friends, and yeah, for the research also. Geopolitics, this is war between Russia and Ukraine, so affected the food supply chain, and future generation of farmer. This is one of the 5 challenges in Indonesian agriculture. But the most is climate change that we are facing right now. That's why we are proposing the idea and how to solve the problem in agriculture by applying the precision agriculture approach. So what is precision agriculture? If we are seeing the description, precision agriculture using advanced technology for real-time decision making, for optimizing resource use, and reduce environmental impact, playing a key role in mitigating climate change in tropical agriculture. If I can share you about the main idea of precision agriculture is only 3. First, optimizing resources. What is resources for agriculture? Water, soil or land, and fertilizer. The other, cost, money, seed, or anything. Yeah, we have to optimize it. Optimize resources. And the second one, we maximize yield. What is yield? Product. What is the unit? the unit of product, ton, kg, or something. We have to maximize it. And the last one is reducing the environmental impact. Because if we are considering about how much fertilizer should be applied precisely, it means we can reduce the impact to the environment. That's three kind of idea is the meaning of the precision agriculture. And in order to do these three kind of activity, we use the technology. Technology for measuring, interpreting, and also applying. Yeah. Yeah, this one. Three kind of activity in the precision agriculture. This is the step by step. This is the data collection, interpretation, and also application. If you can see the first part is we have to know about the condition of the soil map, soil condition of map, and also yield map. If we know everything about the condition in the field, we can manage. For example, the soil fertility, soil condition, and then yield. Maybe we can map which location actually need more fertilizer to grow the yield. This is the idea of the precision. The second one is interpretation. If we know the location that need to be apply more fertilizer, we can make a heat treatment. For example, I will make an analogy for this kind of research. If I ask all of you in this room do you like coffee, everyone? Really, coffee? What coffee do you like? What coffee do you like? What coffee? What kind of coffee? Latte, Americano, aren, kopi aren. Eh, yeah. Caramel macchiato. How about you? Mocha. How about you? Espresso. How about you? You don't like coffee? Oh, exception. Okay, if we say that this kind of a sampling, I make a sample like how many people like matcha, how many people like latte, how many people like Americano, then I can make a recap and then I buy the coffee that I need to give all of you. So it means I can reduce my losses for if I buy, maybe everyone like maybe latte, cafe latte. Everyone like cafe latte. I buy cafe latte, but said no, I don't like cafe latte. I like matcha. I cannot drink coffee. So losses this one. How about this one? Oh, I like Americano. Cafe latte is not suitable for me. Oh, this also another losses. That's the idea of the precision agriculture. Data collection, interpretation, and also application. This kind of cycle should be conducted annually. But the idea is how can we conduct the survey? How can we interpret the result? And how can we apply the agriculture resources in order to do the improvement? We use the application. The next level is smart farming. Some of the people or students always confuse the difference between precision agriculture and smart farming. If someone says that I'm using sensor for my agriculture management, I'm using drip irrigation for my greenhouse, everyone say that this is smart farming, but I said not yet, not yet. If you are using sensor for measuring the condition of the soil and you get the data and you interpret the data, it means you practices the precision agriculture. This is the base, if you can see in the slide. This is the base. But if we are adopting the information knowledge management, means that the knowledge in practical application, for example, in the greenhouse, you collect the knowledge about how can we cultivate the lettuce, for example. How can we cultivate the pak choy? You know the knowledge, and the farmer know how to cultivate it during through years. They have a knowledge. Yeah. Okay, this is the knowledge. So it means not only the technology, but you know the knowledge behind instead of the local knowledge and also the knowledge gathered from the long-term period. This is the from the left side, the information and knowledge management. And the next factor is the automation and robotics, AI, that we have to say. This is the one of the hardest part in the smart farming. Why this is the hardest part? Because if you are already collect the data and you apply the precision agriculture, and the next is how can we use the data for agriculture management? For example, we can do the forecasting for the weather, we can forecast the yield, we can optimize the dose for the fertilizing application, and maybe we can trade also, trade, forgive money. Yeah, this is the important of the AI and also robotics. Robotics help for managing the activity that is boring activity. Can you uh, say what kind of activity is boring activity during the agriculture production? Aktivitas yang membosankan, watering the field. Oh, okay. Another activity that is boring.
Planting, probably, the seeding.
Yes, planting is boring.
Yeah.
Maybe only maybe small size is enjoy, I think.
Yeah.
All you can enjoy. For our plant factory, planting in the plant factory, enjoy. But if you plant in the maybe 10,000 hectares by hand, yeah, it's boring.
I think you will finish next year.
Yeah, next year after you finish your school.
Yeah.
Yeah, the robotic is doing that one. But the one activity that is need like a human sense, what kind of activity that need a human sense? Can you mention? That cannot be replaced by robotics. What kind of agriculture activity that cannot be replaced by robotics? No? No activity? No activity that can be replaced? What is the difference between robot and human? Now robotic can make a decision. Even now you can ask the GPT for you can make a consult about your life.
There is answer from Zoom that
Yeah.
it says is about genetic modification.
Genetic modification, yeah, regarding the human and also the
Yeah.
bio, they can be replaced.
The bioresources.
Yeah, bioresources. But that I want to say is about taste. Do you know about taste? Like I said that, okay, I want to make a harvest for durian. Okay, durian. Everyone like durian, like durian. Oh, really? Okay, durian. Some people they like the rip, ripen, durian. But maybe Thai people they don't like the ripened durian. They like the almost ripe, like crunchy, the crunch one, the crunch one. But Indonesian people they like the overripe. Overripe mean durian matang sekali, yang sangat melendrek itu. Very soft. Yeah, almost like alcohol. They like that one. Indonesian like that one. How about Philippine? You can eat durian in Philippine? You like? What kind of durian do you like?
I don't like Filipino durian. I like tempoyak.
Tempoyak, fermented.
Yeah, yang manis. Yang asin.
Oh,
Sambal tempoyak.
sambal tempoyak. Okay. So this is very traditional, I think, yeah. Traditional food from Sumatera.
It's traditional, but it's also spread across Southeast Asia. that some
Okay.
country also have a similar treatment to the durian fermentation.
Yeah. Okay. My point is the taste is come from human. Robotic maybe they don't have such kind of taste, but maybe some years later, maybe in the future, maybe robots can make a taste. Not taste about the tongue, but the taste about the how to say sense or something. Dalam bahasa Indonesia selera. Apa dalam bahasa Inggrisnya itu?
Taste?
Ya taste ya. Taste, but maybe in English taste is this one. Taste is from the tongue.
I think the feeling.
Nah, feeling about taste. Okay, mix. Feeling about taste. Difficult. Yeah. In the future, I think robot can do that. But up to now, maybe they cannot be replaced at now. Yeah, please.
But how about sometimes we use glucose level meter for harvesting, right?
Yes.
To see if it's ripe. Is it different from what you're saying, the senses?
Yeah.
Is it, yeah?
Yeah. For harvesting, maybe they only use the simple parameter. For maybe the easiest one is we can use color. For example, for cherry, picking cherry for using arm robot is commonly used for the research and also industry. And the ripen cherry tomato is easy to say, oh, this is already ready for harvest. But for example, for durian, yeah, it's different level. Okay, okay. For Indonesian tongue, maybe it's okay. This is ready, but another region they don't like. Yeah, this is very subjective. The many subjectivity, robots have to make a program one by one. But for example, the easy one is for the based on the color, based on the how to say smell. We can use by smell, but the degree of smell is also different. Is it how to say delicious, more delicious, more delicious, or super delicious? Maybe this is one of the category sometimes need to be, I mean, learn behind the robotics. In the future, I think, but up to now, maybe the robot only focus on the color, on the smell, but not so as complicated as people. That's why the now, if you see that we have a profession for testing the coffee, do you know? Yeah, itu not replace yet, because they learn how to make a quality control for the coffee. Long time for learn that one. If we can digitalize that kind of knowledge and put it in the robot, so that profession will be disappear, replaced by a robot. But in the future, I think, but we don't want to replace it. We need the human sense for this one. Okay, we continue. In order to adopt the technology of smart farming, we adopt the new technology. The latest technology is the Industrial Revolution 4.0 and also Society 5.0. This one, the Industrial 4.0 lead to application of the cyber physical system, Internet of Things, and also network. This is the latest technology in Industrial 4.0. We already familiar using this kind of technology. Cyber physical, I mean, we are now using Zoom. It's also one of the product of the Industrial 4.0. We do not consider about where is the location of the Zoom, but we can feel the benefit of the Zoom. We can buy from the online shop, Shopee, Tokopedia. We don't even consider where is the location of the office of the Tokopedia. And we feel and we realize the benefit. And we trust it. How much money you make a transaction in the online market? The biggest money. 10 million juta for buying car? No. Buying TV, television, buying laptop, and you trust it? You trust it. You trust it. You trust it. And me also trust it. I buy this online. Yeah, now this is a cyber physical system. Trust, and we don't know about where is the location, but we can get the benefit. This about the technology. The key technology, there are IoT, big data, 3D printing, and also network. This one of the technology in Industrial 4.0. The other one is Society 5.0. This is about the human. If the previous one is the technology, but this is the human. The first one is hunter and gatherer. Second one is agrarian. The third one is the society in industrial. The fourth is information society, and the fifth is next generation of society. It means that the society that can use the technology wisely. As easier as you can use ChatGPT wisely. How to use ChatGPT wisely? What kind of question, what is the most stupid question that you have asked to the ChatGPT? Anyone? How to? Hmm. Yeah. Maybe I think everyone already tried the stupid question to the ChatGPT. But in order to ask the ChatGPT, you have to give a brief. This is the wise question. To give a brief overview and what is your question and how can GPT responds. It means that you already want to be a society 5.0. You can use that technology wisely. And the second one is do not believe it 100%. Do you believe that ChatGPT can answer every question? Can. They can answer every question. Every question they can answer. But the truth, please think again. Do not believe it 100%. Make a cross check, make a check and balance, and also do not believe it 100%. It can help you for managing your daily activity, but do not believe it 100%. This is the good words, I think, for this lecture. Okay, next. How about the agriculture? Agriculture also transforming from the previous traditional to the AI-based digital. Now we can use the sensors and robotics for gathering data from the field, using Internet of Things to collecting the data, and cloud computing to store the data, and then AI and machine learning algorithm for make a data analysis. The goal of the idea from the precision agriculture is make a decision support system for managing the agriculture production. And who is the benefit? Is the user. User have to use the technology wisely. If they cannot use technology, so it means, yeah, same like you asking the stupid question to ChatGPT. Useless. It means useless. Okay, that's why we propose the agriculture 4.0. It means that the use of the benefit of the latest technology in an industry 4.0, and also the human that is in the level of society 5.0, and then we can get the concept of agriculture in 4.0. This is our proposal for agriculture 4.0, the management, and also the future direction in the agriculture. Okay, I continue for the example of our research, and hopefully that some idea can help you to, how to say, to see how can we use the simple technology to solving the problem in agriculture. Yeah, we have seven research group or research focus. The first is the open field horticulture production. The second one is paddy rice. cultivation. The third is the oil palm plantation management and indoor farming. This is from greenhouse and smart greenhouse technology, plant factory technology, and also the supporting activity is knowledge management and also community development. Okay, let's start one by one. Maybe I will make it fast. So this is the framework for the local and global management subsystem. Maybe if I say this presentation 10 years ago, I remember my senior lecturer said this is impossible. For recording and monitoring weather and also the data from remote 10 years, no, yeah, 10 years ago, this is still, oh, this is not impossible. This is difficult. At the time, still use SMS. Do you know SMS? Short message service. But now everyone use WhatsApp. No one use SMS. That's why at that time, we believe that if we develop that kind of framework, might help the use of the data collection, data monitoring, and also decision for the agriculture production. We built this activity, this framework is in 2012. Yeah, almost 10 years ago, almost. So for the open field, we use the evapotranspiration for the parameter for considering the management. Maybe some of you already know this one, the evaporation and transpiration that come up in the same time, evapotranspiration. And by using that data, we can make a model for forecasting. Forecasting means if now we are in the morning, we want to know what is the value of evapotranspiration during afternoon. So we build the model based on the data, recorded data. This is the evapotranspiration modeling. And if we have the data, we can use it for daily management. Daily management, for example, this device we install in the farmer. The farmer in the outside, they only have the data from our temperatures, humidity, solar radiation. And we can suggest the prediction of the evapotranspiration. And the activity we can record, for example, if they are wilted on during the high evapotranspiration, okay, we can use that data, the recommendation for suggestion in the farmer. Okay, tomorrow please make more water to your plant if you don't want to make it build it again. So this kind of the suggestion or recommendation is useful for the daily application. The AI now can do this kind of task easily. Previously, we have to make a difficult model. For example, we built the detection model, computation of evapotranspiration, but now using AI is simple. And this is the evapotranspiration monitoring. As you can see, the red color, it is in the mid of day, high evapotranspiration that might affect the plant condition. And in the red hand side, you can see, this is the actual and predicted evapotranspiration. It means that our model can close to the real condition. Okay, the other one is the irrigation control. This is one of the favorite topic for the research, irrigation control, but we can use the two kind of activity based on the climatological and also soil moisture. Climatological based controller mean we can use evapotranspiration, and soil moisture mean that we use the sensor inside the soil. So we scan the two kind of input for irrigation. And this one is very useful for reducing the water consumption up to 13.37% comparing with the threshold type irrigation. And the other one is hydroponics. This one is also interesting topics about how can we manage the nutrient in the outdoor hydroponics. Okay, this is a GPS-based tracking system. So this is for the tillage operation, because we know that in the tractor operation, sometimes we feel that the trajectory, the trajectory, lintasan traktor is not as good as the plan. So we use the kind of system for helping for evaluation the tillage operation. And the other one is real-time IoT for monitoring the quality of pH level of coconut in the field. So this idea is come from if we want to know the condition of the nira, what is the English of nira? Sub, 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 yeah, sub in the field. This is the idea. We want to measure the condition and the quality of the sub, this one. Yeah. Okay, because time is limited, I want to skip it to the plant factory technology, because after this one, I think that we go to the plant factory. Okay, is there any question before I present the plant factory? Yes, please. Yes.
Okay, sir. Thank you for the presentation. Previously, you showed us the vision for agriculture, right? So I I believe previously when you showed the automation and the IoT, does that increase the price? Of course, it's more faster for the production, but does that increase the price of the product or lower it to the local?
Mm.
So my question is it gonna affect the price in the future or just is still the same? Because it's manually everything, especially here in Indonesia.
Yeah.
So everything is manually. So
Yeah.
the price is still maintained.
Yeah.
But with using like advanced and as you mentioned
Yeah.
before, it's really expensive. Is it that can affect the price of the product?
Okay, thank you very much. Mr. Abdullah from Yemen. He asking about if we introduce the technology to the local farmer or maybe small medium enterprise, is it increase the price of the product or no? Yeah. If we use the technology, sometime we have to change our mindset, yeah, mindset that the technology is investment. Technology is investment first. We can introduce the technology and then step by step we can get the how to say the improvement, maybe not in the instant time, because we have one of our partner in Sriharjo, small medium enterprise farmer. We introduced the nutrient control. He said that, oh, this technology help us for controlling the nutrient. Before I use the technology, every day, every morning, I have to check the pH and also the ppm every morning. They said, now I can manage it from smartphone. Okay, that is the benefit of use technology. The other side, I have to pay for the data, packet data. And then the second one, we have to pay the electricity. And the other one, they have to pay maybe if the sensor is broken, they have to replace with the new one. But from the benefit and the cost, this is one of the good option for continuing the technology. Yeah, the investment. Yeah, if we say that the technology is cost, mean, oh, this is very hard to pay. But if we say this is investment, so in the future we will get the benefit. Not only benefit about the easy, how to maintain, easy for monitoring, but it's also increase the productivity, the quality of the product. The produce also the quality, because the nutrient is homogeneous in the standard comparing with the previous one. So the quality is increased. They plant the, I would say, the vegetable, pak choy vegetable, and the result is homogeneous. Previously difficult to make it in the same level, but now they use it's easier because we control the nutrient automatically. Yeah, the cost may be increased, but the quality is also following. That's why we consider about the low cost technology, not the sophisticated. That's why we consider the most important things in the smart greenhouse is the nutrient control. That's why we introduce only the nutrient control. How about the temperatures? Oh, temperatures can be ignored because in Indonesia, open the window, we can reduce the the heat. Yeah, humidity temperatures can be reduced by using the um, open the window and also blower like a fan. But the nutrient is the most difficult. That's why we only the difficult things that we control. Yeah, hope this answers your question.
Okay.
Yes.
So that's for the farmer. What about the consumer? Is it the price still the same? Let's say a pilates today is uh 10,000. And
Yeah.
the farmer will say the next time, is this by IoT system is 20,000.
20,000
I don't
twice.
care. So is it like can I maintain still for the consumer the same price or
Yeah, good question again. If the price is twice or maybe change increase, how about the consumer? I can say in the same case already happened in my plant factory. The plant factory price is at the time is not not as expensive as in the outside, but from the feedback from the customer said that, oh, the vegetable is clean without pesticide, no apa ulat, there is no, yeah, yeah, pest contamination, and also the taste is crunch. Yeah, after that the customer can choose their option like, okay, I choose this one because this is healthier than the outside, this high technology, I choose this one. Why this one is cheaper? Oh, maybe this is planted outside, or this is used manually. Maybe they sprayed using pesticide or something. Yeah, at the end, the customer has choice. Maybe healthy life. Okay, I choose this one. And the other one is they don't care about the healthy or apa aja yang penting okay. So they will take one. Yeah, at the end, the customer have a choice. Have a choice. The same idea, like if we make a good product for the, I mean, healthy people, okay, if they consider about this one, so they will give it. They will take it. But for they don't understand it, yeah, it's okay. Maybe this is not your target market, I think. Yeah, hopefully this answers your question. Okay, another, yeah.
Hello, my name is Alia. I'm from Indonesia. I have a question regarding your statement about the taste. You said that the taste cannot be replaced by AI. And I'm wondering that we do have flavor chemistry when we can learn about the taste and aromas from the chemical compound. Maybe we can put the data from flavor chemistry to the AI so that we can use that. But I do realize that if we use that, we're gonna generalize the product to one same yield, I mean, and which led me to my second question for mass production and for the future and for the consumer, is it better to have a subjectivity or generalism approach for the crops yield? Thank
Okay.
you.
Okay, thank you, Miss Alia, for the question. good question regarding the can robotic make a taste at the time. This is a maybe in Indonesia, taste that I mean is selera. Selera make like not about rasa ya, tapi selera. Selera. Selera like feeling about the how can we uh, yeah, about the chemical compound. Maybe they can use the sensors, and also for the smell, they can use electronic nose for maybe characterizing the smell. And the other one is maybe from the textures. We can use that kind of sensors, and then robotics can uh, understand the pattern and then make decide, oh, what's really happened to this object. But the other one, the important thing is like sense, or how to say, sense and feeling is that cannot be replaced. But the taste is, yeah, maybe it can be used for that sensor.
Maybe you mean the preference of each consumer is different?
Yes, yes, preferences. Yeah, preferences. Then the other one is you are asking about, can we make a generalize for that kind of model? Yeah, this two option in the development of the system. The first, we can make a specific approach, because, for example, if we make a electronic nose for durian, in the case of we are discussing, maybe there are many kind of smell of durian that made specific in the different place. They have a different characteristic. And the other one is the general. Maybe we can use general model, for example, for detecting if the durian is mature enough, ready to harvest. Maybe that kind of two kind of activity we can use for approach for that kind of model for the detecting the taste that kind of fruits. Yeah, hopefully this answer.
And for like, if we're gonna distribute it to the consumer,
Mm.
is it better if we have, uh, if we consider subjectivity, or is it better if we generalize it? Because considering the cost of the like fertilizer or everything, if we going to consider the subjectivity, we're gonna need a lot more things to buy, a lot of different things to buy. If we're gonna generalize it, then we're just gonna have to buy one thing. So which one is better for our, like our system and
Yeah.
for the consumer itself? Thank
Yeah.
you.
Okay, good question. Um, we can answer this question based on the 2 point of view. First point of view, as researchers or engineer. I'm engineer, so I have to prepare in the specific one. I have to prepare. For example, for durian montong, for apa musangking, for we have to make a model every. As an engineer, I have to make all. But as point of view, as I mean the producer mean that if the sensor will be sold, is be sell to the market, so the general one is profitable, because if they make a specific, maybe like the preference is different. Oh, buy this one, and then considering about the production cost of the sensor, it's might difficult. That's why this 2 point of view. As researcher or engineer, we have to provide all. But if you want to sell that sensor as a producer, maybe the general sensor that might people want to buy, many people want to buy, so this is maybe profitable. For example, the easiest one is sensor for detecting is if the durian is mature or ready to eat. Is there any sensor right now for durian? You make a like this. Can you do that? Easy. Only the durian seller they know. Only by uh ribs. Yeah. And sometimes zong. Sometimes, oh, okay, this is good. It's ready. Rib enough. And then they put. That's why they make a guarantee. Sometimes the durian seller, if not ripened yet, I will replace it. This is one of the guarantee. So in our consideration, if we have a sensor that can detect such kind of the ripening, I think is useful only for detecting the ripen. The general one. For the specific, we can use it for musangking, for maybe for montong, maybe for the maybe the specific durian. I think it's very difficult each for each one. Okay. Okay, thank you. Another question?
Okay, sorry to interrupting, but due to the time limitations, maybe another questions can be asked in the plant factory
Okay.
visitation.
Yeah.
But there is one questions from
Yes.
the Zoom chat asking about what is the main goal of using precision agriculture in farming, and maybe after that a quick slideshow about plant factory before we move to plant factory.
Yes. Okay, thank you for the question. What is the main goal of using precision agriculture in the farming? The main goal is we want to develop the decision support system for managing the agriculture production. That is the goal. Decision support mean if we want to do something, this it have to be based on the data, not only based on the feeling. I'm not saying that the feeling is not good. If you already make a planting activity almost maybe 40 or 45 years, maybe your feeling is already sharp. But if you don't have such kind of experience, so based on data is the good option for decision support system.
Okay, maybe a quick slideshow about our next visit at plant factories.
Okay, we will visit our plant factory in the basement floor. Maybe some of you will divide it into two groups, I think, because the plant factory is not so big. Maybe we can see small plants there. If you see in the pictures, yeah, this is our plant factory. We only have two rack. It has one, two, three different levels with artificial lighting. It's equipped with nutrient control, and the dashboard is managed by the edge computing connected to the internet, and we can access the data from the remote dashboard. It also has a decision support or data here in the cloud system. So what is the difference between our plant factory and the another plant factory? Our research also supported several research has been done in that plant factory. That is the benefit of we have that plant factory. For example, we have a simulation for lighting based on the sinusoidal for reducing the water stress and also plant stress. So we also have developed the robotics also here. The position of the camera is based on the finding the location of the plants. This is the robotics camera. That find the roots of the plants. Also thermal imaging and also the measurement of the photosynthesis. And also PPFD and so on. Okay, maybe we can discuss later in the plant factory while waiting for the maybe the order come. Maybe we can go to the plant factory.
Yeah. Please give a round of applause for our speaker, which is very insightful. I believe all of you have a lot of questions in this room, but hold it for a moment. And I think before we move to a plant factory in the basement, we would like to appreciate Dr. Andri Prima Nugroho for giving such an insightful presentation.
Okay. Okay. Thank you so much, Mr. Andri Prima Nugroho, PhD, for being an insightful lecture about AI and IoT in smart agriculture. We would like to give the appreciation certificate that will be given symbolized by our moderator.
Okay, Dr. Andri, please come forward.
And also we would like to thank to Dr. Priska Rina Lestari, who led the discussion before, and the certificate of appreciation will be given by the chairman of the 7 summer course program, Dr. Fiameta Ayu Purwandari. With the station of appreciation certificate already implemented, then the
Yeah, the manufacturing idea is we want to grow the plant inside the room. Like I said, maybe in the future, if maybe we cannot grow, and or we are like manager of agribusiness that we want to produce more yield in the controlled environment, control number of yields to supply, for example, hotels, restaurants, all this the vertically growth inside the control farm and make nutrient control, and we can get the data. The data is stored that is of the daily activities. We can understand the numbers of and also remember it's Franklin and it's launched in 2024. So the activity is for research and also production. We also sell the vegetable to consumer but the cleanliness that's they like without pesticide. And this is the pictures that we mentioned in my slide. It's about the high flow, about control, light things, CFD analysis, also for the fruits from the okay, we go inside. Yeah. Okay, please come. This is the control panel for the plant factory. Yeah, this plant factory we collaborate with Inastec. Inastec is the agricultural company technology that they build the rack. The name is Insira, and we have discussed the design about how the distance and the size of the material. So we discussed with the Inastec for building that Insira. So this collaboration works. And also this one, the control system, this is built by the Inastec or the Aman. So we can control for the light, we can make a automatics or manual. For example, this is the manual, we can turn on. So we can make it automatics. The grow light and also fan for the circulation. And the important thing is the nutrient for dosing. So each rack we can make a setting for the automatic for the pH or electrical connection. The temperature inside is actually this dashboard, but I don't know exactly, but the states are all the dashboard. What box that? This group is lettuce. Lettuce is the most before market like lettuce. Everyone lettuce.
Cash for the yield, how many kg that can be produced?
That's
For this
one cycle.
Yeah, one cycle.
Yeah, one cycle. We have cycle because it's following the request from the hospital. That's why we are preparing us about
For the it's this year or
UGM. They only build and
sponsor.
Yeah. One manager doing this one. No, another manager. But currently he is in Jakarta for Expo.
What is the function of
Fan for circulation. Because sometimes if you consider that sweaty, do you find the sweaty sometimes in your armpit? Yeah. Sometimes the plant is also feeling like that. So the air circulation is the flow of the excess water.
Because doctor have have learned about this. Is there chance for AI and IoT will be hacked because our data privacy also can be hacked. Why is it for this type of fund?
Sometimes maybe possible because all the data is going to the cloud.
Yeah.
Sometimes you send that to cloud, so they can pick up it. Not so dangerous.
If
Yes, sometimes difficult to. Up to now, maybe environmental data for the plant group is not so serious. But in the future, I believe. Automatic, yes. Not so hard. The hard one is sometimes I think link or
Because using with farming like this. Con đây là chua tị. Tị kim, xin bị kim.
Instagram, so we have a plant factory. You can have more.
It's not very yeah. So that's just yeah. What is there's how can you reduce the bacteria?
We have a UV.
How is it in the water or
The circulation sometimes we
pass
pass the UV.
which part?
Not installed yet. Not installed yet. We have another reasons for that one. Yeah. For reducing the unimportant one.
The residue.
Yeah, residue.
What about in microbial activity?
Yes.
In the soil, we have nematodes, everything, but here it's not depend on water.
What are
Also, in the microbial, because we have research mycorrhizal fungi, the artificial mycorrhizal fungi.
Oh, tapi we only study
So that it can grow bigger. Yes, very big.
Oh, currently we only use water for media.
This is the we have
Bigger, yeah.
so consider
No. Because we are not enough knowledge to do that. Because it started 1 year, so we still and we are focusing on the technology. So maybe in the next stages we will consider that. Okay, any questions? Okay, Mas, please.
Allow me to introduce myself. My name is Anta, and I'm from Universitas Gadjah Mada. So as we know that this facility is relying on electrical power, right? So what is the prevention? As we know, we are here in Yogyakarta, sometimes the electricity is going down. And when it happens, is that will impact so much on this plant factory?
Yes, definitely. Because all of the activity is based on the electric, so if the electricity goes down, and we are problem. One of the idea is we are like hybrid system, for example, using solar panel energy, and we make a storage using battery, and also hybrid system. But it's not possible now. We get big money. Just the challenge.
Actually, I have a question. Yes. My name is Mada. I'm from Universitas Mada. And as I can see, when we plant this lettuce in the plant factory, it will have the same uniform result. The problem is when there is an infection, and of course it will be uniform. So what is the SOP for manufacturing when they have contamination inside? Thank you.
Yeah, thank you very much. Yeah, the managers always check every morning. They check first. They check the nutrient circulation, check the environmental condition, and check plants. Sometimes if the plant is die, they have to replace as soon as possible because during one cycle they have to make a good number for the supply to the hospital.
Yes. And for the next question is, when we have this controller room for the lettuce, will the yield will be faster or slower?
Depend on the supply of the nutrient. So that's the benefit of we are growing the plants inside the environmental control room and the nutrient control, so we can make an expected harvesting time. If we supply more, then maybe it's faster for the harvest. But in the range time, not in the as fast as 30 days.
Thank you for the answer.
30 for
Why people realize this? But because what I've studied is that agriculture is not only part. It's really
chemical.
Chemical,
Yeah.
even the some fertilizer.
Yeah, in Indonesia it's difficult to find the organic and extract. At least now they want to get clean and healthy. Clean and healthy.
So the problem that need to solve for this technology is that hygiene. Hygiene is a problem there.
Because the previous one is the planting outside, soil or something. So they prefer this one. Okay.
Specific pesticide are
Side.
I know.
Only nutrients. Only nutrient. 80 weeks. 80 weeks. Only the nutrient. All the budget is 350 juta.
So when
Yeah, from the SOP, yes. Sanitation, you can other condition.
because one thing that I've seen in agros in Kuala Lumpur, they supply vegetables that has spray.
Yes. At the time, yes, for the preparation.
So biosecurity is very tight.
2 years, but not so applied. Yeah. It should be. It should be. It should be. But sometimes the manager is not as strict.
The manager is lecturer was very so this
Yeah. Reinforce selling and also preparing the seeds. But they have sometimes they hire. Yeah. Part-time. Maybe
security.
which university you are on?
I don't know if you behind this.
You get better.
I will tell my lecturer so that we can make something.
Yeah. Please. Any question? Yeah, percent temperatures, 10% humidity, and nutrients. Then, yeah, temperature humidity as one of CO2. CO2, no, CO2 can only know. We only monitor the CO2. So only three temperatures, humidity, and nutrient. Oh, light, yeah, but light is only on and off. So, like you don't have insect protecting and CO2 has instead here like ants and yes, yeah, some use actually we don't use pesticide. This is one of our motivation that this is pesticide free. That's why sometimes the student is checking everything, like in the morning checking the condition of the plants. If they find something, so they will pick up. Meanwhile. Yes. Yes.
I have to ask the soil because the soil we change soil and the data will change. So how do you use your soil from getting the same area or to other area?
Soil?
Yes.
This without soil.
We don't use soil.
We don't use soil. This is the soilless. So only water.
Oh,
yeah, only water.
With the nutrients.
So water flow. Yes, and then the roots is inside there. You can pick up nutrient from the roots without soil. Soilless.
But in real life, we have to observe standards. So how do you we don't where we have to
Yeah, there are two options there. If we want to use soil, sometimes we cannot control the cleanliness. It's vegetable will be consumed by the mosquito. They prefer the clean one. Which university?
It's far from kitchen.
Which university? I'm from the north, western part.
Yeah.
You are in the metropolitan.
Yeah, last year I went to Kyushu University for my conference.
Very nice.
Eksklusi
lagi. Eksklusi lagi masalah.
Makasih, Pak.
Thank you.
It's just who just graduated.
Ask him.
Satu Pak, jadi satu jadi.
Saya 2 kali.